back to the new video of this channel. So today in this video I will be solving a problem which is stranger printer Leetcode 664 problem. So let's see the problem statement. So problem is saying that there is a stranger printer with the following two special properties. So the printer has two properties. The first property is the printer can only print a sequence of a same characters each time. It means if I press the printer in single time, that will print the sequence of same character. And the second property is at each turn the printer can print new characters starting from and ending at any place and will cover the original existing characters. It means like if I press the printer and if it follows the first step, it means if it prints the same character a simple. And if I want to change the if I want to modify the new string, that is in previous the string was is open a, but if I want to modify that string, then we can use the second step. And given a string s, return the minimum number of turns the printer needed to print it. So the second step is basically this: if I have all a's and I want to modify the middle a's like a to b, then it will be something like a b b and a. I can start from any index and end from end at any index. So it is saying this. Let's take this example. So example one is AAABBB. If I want to print this string, so what I can do is basically I can print triple A, then first then print triple V. So it is very simple. First I'll press the printer and it will print AAA. Then again I'll press the printer and again it will print BBB. So total number of steps will be two. Let's take this example. String is ABA. So firstly, what I will print is print AAA, then print B from the second place of the string, and which will cover the existing character A. It means like firstly we are printing the all A's, triple A. You can see. Then we are modifying the string, that is ABA. So total number of steps will be two here also. So let's see the approach for this problem. So approach is very simple. You have seen the example how things are going on. Now understand how the inner circle is going on, like AAA and BBB. If I start, if I am starting from this index, like I am taking this part and this part separately. So you can see if I print AA, then it will take one step. Then if I print A and triple B, it will take two steps. So the total number of steps should be three, but the answer is two. So let's see how this is going. Like another way is I can print all A's and all B's separately, so the non total number of steps will be two. So that is perfect. So now let's take the example ABA. If I separate this string, then it will be A and BA. So for printing A, it will take one step, and for printing BA, and it will take two steps. Let's separate it out again. Now the second thing is I can separate it out like AB separate and A also. So for printing out AB it will take two steps, and for print out the A it will take only one step. So total number of steps will be three, but here the answer is two. So you can see here similarity is there, like first character and the last character of the strings are same. You can see A and A are same. So in that case, what we will do, if the first and last characters are same, then we will subtract minus one in that case. Like you can see the another example. If I take this here, if I want to print AA, then total number of steps will be one plus one, because if I am taking the another case like first case, so if I print A separately and print A another separately, so it will take two steps. But we know that if I want to print AA, I will press single button in that printer, so it will automatically print AA. So total number of steps should be one. So here you can see the first and the last character of the string is same. So in that case, what we will do, we will simply return minus one. Sorry, simply return minimum number of steps minus one, because I have to subtract minus one in that case. So the case is if s of I equals to s of j, it means I am taking the pointers I and j here. So the in that case the answer should be answer equals to minus one. So try for all possible locations k from I to j. Like I have this string A B C D E F G, and I am starting from the first pointer and the last pointer is at 0, 10, -1 and -1 index, and I am taking a pointer k. This will separate out the left and right part. So the minimum number of stacks initially will be int max, and what we will do, we'll apply a loop that will go from I to j, and I will find out all the minimum number of steps that will be a minimum of solve of I to k, then k plus 1 to j. I to k, this is the first part, and k plus 1 to j, this is the second part, and k will change again and again. So because the in this loop, k will change, k equals to k plus plus, so it so that it can separate out all the possible ways. So here you can see the recursion is, we have multiple cases, we have multiple choices, I can say. So recursion can apply here, and if you will create a tree, or you will create a graph for this, then you will find out like there will be some repetitions also. If you will see like def and def are coming same pointer, like so in that case you don't need to solve the repeated part. So in that case we can use gp here, so for optimization purpose, so we'll use gp. Let's code it out and see how things are going on. So firstly what we'll do, we know I and j are changing. So we are taking two pointers I and j, and both pointers are changing, so that's why we'll use 2ddp. So let's create out the 2ddp vector of vector int dp of size n plus 1, comma vector int of size n plus 1 comma -1. I am initializing with as -1, and now let's initialize int n equals to s dot size. Now you can see we have created a dp here, and it's a integer, so I have to return my answer. So let's create the solve function. In solve function I am passing ith pointer that is initially at 0th index, and jth pointer that is initially at n minus 1 index, and I'm taking the string and also dp. So let's create it into, sorry, into solve, and in solve function int I comma int j comma I can write const string s, or ampersand text, and also dp I have to pass. So let's copy it. Yeah. So you can see here. Now I have to write some base cases. So the base cases can be if I equals to j. In that case, if both pointers are at the same index, so in that case I have to return 1. Now, if it's a memorized solution, so I have to write a condition if dp of I and j not equals to -1, then also then and I can return dp of I of j. So dp of I of j. After this, I will initialize into, I can say minterms mini, or minterms can be if int mini equals to int max. It is the minimum number of steps or minimum number of turns. Now I will apply a loop that will go from int k equals to I to, sorry, int k equals to I to k less than j and k plus plus. So now I have two ways, like left part and right part, and both part I have to manage. So mini will be minimum of mini comma solve of first pointer will be at the ith index, so I to k, I comma k comma, it's a string, so s comma dp plus again solve function, it's a recursive call, so I to k I have managed. Now k plus 1 to j I have to see like if s and dp also. Now I have find out the minimum number of steps. So after that I have to check a condition, because our condition was this one also. If the first and the last character of the string are same, then we have to return, we have to do the -1 also, minimum number of steps -1. So in that case dp of I can simply write return dp of I of j equals to, you can say s of I equals to s of j. In that case, mini minus 1, otherwise mini. So now let's run and see if this will work or not. That is working perfect. Now let's submit it. You can see it is working perfect. Now let's discuss about time and space complexity for this solution. So the space complexity is very simple. We are using 2DDP and both have size n plus 1 and n plus 1. So it will be something of big of n square. Now let's find out the space complex, time complexity. So you can see there are recursive calls, two recursive calls. So big of n square, and both recursive calls have a loop that is going from k equals to I to k equals to j. So big of n square into n. It's a big of n cube solution, but it's a optimized solution. You can use a top down approach for further optimization, but it's a optimized solution. That's why it is passing all the test cases. Because the time constraints are very low, that is going from 1 to 100. So big of n cube will be 10 is to power 6. So that is perfect for the running out the code. So this is the code, and if you find this helpful, then please like, share and subscribe. So, bye.